the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is part of an introductory series for linear algebra here, and this is the second video in this series. I'm just going through a bunch of little definitions, and I'm trying to make each video pretty short here because really you should already know most of this. So let's go ahead and talk about the definition of a system of linear equations. Well, a system of linear equations, also known as just a linear system, is a collection of one or more linear equations involving the same variables. Now, just a heads up, when you're going through linear algebra and you're learning all the definitions, or I shouldn't say learning, you're reviewing all these definitions, it is important to note that many of the definitions that we're reviewing actually have non-linear versions as well. So there is such a thing as a system of non-linear equations. However, that's not the purview of linear algebra. So we don't really talk about that here. Just giving you a heads up. So let's go ahead and take a look at an example or two of linear, and we'll throw in a non-linear system as well. You should probably already know this from your old school algebra. However, a linear system or a system of linear equations is something of the form that is a collection of linear equations, and what we like to do is find an ordered triple. That's really the goal, is to find an ordered triple here that satisfies each of those equations simultaneously. That's not what we're going to do in this video, but that's just the idea when you're handed a system of equations, is to find a solution to that system. Notice my notation here. I use subscript notation, x sub 1, x sub 2, x sub 3. Notice each of these equations has or shares those variables in common. Even though the third equation doesn't have x sub 1, it's not required that they all have coefficients that are non-zero. So x sub 1 in this last equation has a coefficient of 0. That's perfectly fine. There's nothing wrong with that. We use the subscript notation in linear algebra because you're likely going to be dealing with systems that are super large. You'll run out of letters in the alphabet if you decide to use X, Y, Z, A, B, C, R, S, T, L, that type of thing. Because real world systems are on the order of hundreds of variables or even thousands of variables. So you do not want to constrain yourself to just the alphabet. It's much better to have indexed variables like this. Just get used to that and try your best to understand the reasoning behind it, because that's going to help you as you move forward in linear algebra and when you deal with matrices. Let's go ahead and take a look at a different version of a linear system. Notice in this linear system, I just have two equations, and each equation just has two unknowns. Also notice I don't have it written in a nice pretty form. The pretty form, which is what I had up here where we had everything stacked nicely, right? I had an x sub 1 column, an x sub 2 column, and an x sub 3 column. And then I had a column for the right-hand side constants, right? So that is not a requirement to be called a system of equations. You could write it like this, where you don't have the columns aligned. That's perfectly fine. However, in the long run, you really want to align things with columns. So you could rewrite this system here as x sub 1 plus x sub 2 is equal to 3, and then x sub 1 plus x sub 2 is equal to 4. I wrote down a system here, or made up a system here, that has actually no solution. If I told you I'm adding two numbers and they add to 3, and if you add those same two numbers and they add to 4, you should probably say there's no such two numbers, because there aren't any two numbers that both add to 3 and to 4 simultaneously. So there's technically no solution to that system of equations. Even though we're not running around trying to find solutions, that's just a heads up, there's no real solution to that. Let's try another set or another linear system. That is a linear system or a system of linear equations. It has more unknowns than it has equations, and I will just let the cat out of the bag right now. You're going to learn at some point in this course that that's called an underdetermined system. That means you don't have enough information to be able to solve it. You need at least as many equations as you have variables to be able to solve that system. So that's just a heads up that we will run into that definition at some point in the future. Again, we're not solving these, so it's no big deal that you don't know that yet. You don't know the name underdetermined or overdetermined. There is such thing as overdetermined when you have too many equations, or I should say when you have more equations than you have variables. This would be called overdetermined. And I might as well write it up above. The one prior to that was underdetermined. Again, it's not important that you know that language right now, but just introducing it kind of helps out a little bit, I suppose. Not that we're solving them yet. And finally, let's go ahead and introduce a nonlinear system. So you can see that this system right here has a nonlinear term. So this is called a nonlinear system. It can be solved, however, we're not going to solve this style of system in linear algebra. Linear algebra really focuses on solving systems like these right here. All right, so that should give you a good idea of what a linear system is, or a system of linear equations. And I also kind of described why we're using the subscript notation here. So both of those things are kind of checked and out of the way. In the next video, I'll start talking about solutions to systems. I hope to see you there.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.